Hello, my name is Luis Ángel Ruiz Fernández. I'm a professor at the Department of Cartographic Engineering, Geodesy and Photogrammetry of the Polytechnic University of Valencia in Spain. I will introduce Lidar systems, operations, and types. There are different types of Lidar depending on the distance from the sensor to the target: spaceborne, airborne, UAV-based systems, and terrestrial laser scanning. There is an increase of point density and a decrease of footprint size from spaceborne to terrestrial systems. This is important to consider depending on the detail required for a particular application. An airborne laser scanner system has several components: a unit transmitting and receiving the laser beam, an optomechanical scanner, a control and storage unit, a global positioning system providing the dynamic location of the sensor, and an inertial measuring unit that registers the movement around the three main inertial axes. When the system sends a pulse of energy impacting the objects of the landscape at different heights, the time spent to return back to the sensor is measured, providing the exact coordinates of each element impacted. Here are the typical specification ranges for some of the parameters used by a Lidar system: duration of the pulse, incident angle, wavelength, or pulse emission rate. There are two main types of Lidar: discrete and full waveform. In the discrete Lidar, either one or several returns are registered from each energy pulse, so we obtain a set of three-dimensional coordinates of the surface at different heights, conforming what we call a point cloud. Here we see a point cloud profile of a forest area. Discrete Lidar systems usually collect multiple returns from the same laser pulse, coming from buildings, trees, vegetation, and terrain. In this example, we have four returns. The first return comes from the top of the canopy, the second from the middle part, the third one from the lower canopy and shrubs, and the last return comes from the ground. In the full waveform Lidar systems, the complete return signal is registered, digitized, and stored, usually in 256 registers. So the laser scanner energy pulse interacts with vegetation and terrain, generating a complete wave based on difference in elevation, the proportion of pulse intercepted by the vegetation or soil, and the reflected energy from the surface elements. So at the end, we obtain a full wave characterizing the elements and objects above the terrain. There are two main types of full waveform Lidar: small footprint and large footprint. Small footprint is typical of aerial and UAV laser systems and large footprints of satellite systems. In small footprint systems, all targets individually contribute to the waveform type, but the probability of registering information of the ground is lower. On the other side, in large footprint systems, the last pulse usually reaches the ground, but each return is a mix of several contiguous targets with different properties. Another type of Lidar is the bathymetric Lidar, based on the use of pulses with two different wavelengths, near-infrared and green. The near-infrared energy is reflected from the water surface, with the green pulse penetrates the water and is reflected from the bottom. Subtracting the registered heights obtained from the bottom and from the surface allow us to calculate the water depth. Here there are examples of bathymetry maps, coastal areas. As final remarks, we can conclude that Lidar systems can collect point cloud data at different densities and footprints to be adapted to a diversity of applications and scales. Full waveform data are complex to process, but they have more penetration in the canopy than discrete systems. Bathymetry Lidar systems are used to register water depth in coastal areas based on the use of pulses in two different wavelengths. Thank you for your attention.